Okay, intrepid AP human geographers, because of the coronavirus, which now has a name, um, we are doing all of QSI Unit 8 via distance learning. But do not panic because we've already done half of this content. So this is QSI Unit 8 Industry, but it's College Board Unit 7 Industry and Development. We did development as a part of Unit 2. So we're doing QSI Unit 8 as industry, and then we'll back up and do QSI Unit 7 as urban for the last unit. And urban is the 6th unit for College Board. All right? Yes, it's confusing. Just try to not pay attention to all the weird numbers, but know these topics 7.1 are as a part of CED Unit 7, which is the last unit in the College Board. So today we're going to talk about the Industrial Revolution. We're also going to talk about a little bit of review of economic sectors and then talk about theories of industrial location, why industry is where it is. So we're continuing with our enduring understandings of industrialization. Past and present has facilitated improvements in standards of living, but it's also contributed geographically to uneven development. So we've already talked about a lot of this, these concepts when we talked about development in QSI Unit 2. So 7.1 is the Industrial Revolution and how it facilitated growth and diffusion of industrialization. Our essential knowledges today are industrialization began as a result of new technologies and was facilitated by the availability of natural resources. As it spread, it caused food supplies to increase. We already talked about this when we talked about the Industrial Revolution as the second agricultural revolution, and populations to grow. It allowed workers to seek new industrial jobs in the cities and changed class structures. So we talked about this in agriculture. The second agricultural revolution, which is parallel to the Industrial Revolution, changed the way farming happened. People were not needed out in the rural areas anymore to farm, so they moved en masse into the cities, and it changed the way our world is structured. As a global population, we continue to urbanize at a massive rate. And our final essential knowledge of 7.1 is investors and industry sought out more raw materials and new markets. Right? We've already talked a little bit about this when we talked about political. So I am in the industrial age. The industrial age requires a lot of raw goods to shove into my machines to make into products. And Europe is tiny. So as a producer of raw goods, it ran out of raw goods and looked for new places to find those raw goods. And they found those new places in Africa and in Asia. And so this caused a period of imperialism. And remember, imperialism is the giant umbrella topic. It means controlling another state in some way. And one of the types of imperialism is colonialism, which is what happened during the Industrial Revolution, where political states would go into another place and control them directly and create governments and infrastructure, etc. All right, so overview of the Industrial Revolution. The hearth was in Great Britain in the 18th century. I've seen 1750 as the start date. Around 1800, as we discovered in the population unit, that's when the population really began to climb, if you remember the Hans Rosling video. But the Industrial Revolution started in around 1750, and so it took 50 years for the changes of the Industrial Revolution to affect demography or population. As people learned to use water power and coal energy to manufacture goods, they saw a large increase in agricultural productivity, population, and wealth. Industrialization diffused throughout the world and it reshaped everything. Everything we are is because of industrialization. And then we are going through our technological revolution right now, and it will eventually, we are in the middle of the changes, so we can't see them. So just like the Industrial Revolution, change happens gradually over time, and then suddenly everything is different. So the Industrial Revolution, as a definition, was a set of changes in technology that dramatically increased manufacturing productivity. It reshaped how people worked and how they behaved and where they lived and how they related to each other spatially. Remember the word spatial, S-P-A-T-I-A-L, is about where things are. So the spatial changes of the Industrial Revolution, just like the spatial changes of the second agricultural revolution, is spatially moving people from the rural areas to the urban areas, economically changing them from primary sector jobs to secondary sector jobs. So the Industrial Revolution again started in the mid-1700s. The quote here it was like throwing a rock into a pond, right? You toss a rock into the pond, it goes bloop, and then there are ripples that go out. So the big ploop of the rock was Great Britain, and then the ripples that were going out started in England and the Netherlands, really close to Great Britain, and then eventually got to the United States and Germany and the rest of the world. Now, why did the Industrial Revolution start in England? Look at this map and see if you can figure out why. So the purple spots on this map are coal mining. So look at how much purple is in the United Kingdom. So they had a glut of coal. They had a lot of coal for how tiny that island is. And for a long time, coal and water were the only two sources of energy. So Great Britain had what it needed to start building giant factories to produce things. By the mid-1800s, it had spread to Germany and the US, as I said before. And by the early 1900s, it had reached all of Europe, Japan, and parts of China and South America. And today, most of the world is industrialized. There are pockets that aren't, but most of the world is industrialized, in different levels of industrialization, of course, as per the Wallerstein world theories, right? So the core countries are industrialized, but they're post-industrial, which we will talk about in the next several topics. And then the semi-periphery countries are industrialized, and the periphery countries are starting to industrialize. All right, so on a smaller scale with individual countries, this is how diffusion happened, how the Industrial Revolution spread. First, factories were built near the sources of rivers, or sources of power, like rivers, right? So the very first factories were on rivers, and then when they discovered coal, they would build the factories near the coal deposits because it was they didn't have transportation really fixed. There were no railroads yet, so you didn't want to transport all that coal. You wanted to just mine the coal and put it into your factory. And then as they figured out more transportation routes, building roads, canals, harbors, and railroads, factories could be almost anywhere because you could mine the coal, put it in a train, and take it somewhere else to create energy to run the factory. So industrialization began near rivers and coal deposits and then diffused wherever railroads and roads and canals would take them. As the Industrial Revolution progressed, improvements in farm machinery, this is the second agricultural revolution, remember, increased agricultural productivity. This is a review of our agriculture unit. The Enclosure Acts also increased agricultural productivity. There's a reminder of the Enclosure Acts. And keep in mind, and this is, well, it's not hard to imagine, but it's something that's easy to forget. Great Britain was a developing country at one point. Right, so before the Enclosure Acts, most people in Great Britain lived kind of in a pastoral nomadic existence, right? They had small farms and their sheep and their goats and their cows, they would wander them through the countryside like pastoral nomadism in developing countries now. And then the Enclosure Acts changed that. They started building fences and hedgerows that prevented people from taking their cow anywhere their cow wanted to go. And that changed how those farmers and those pastoral nomads could make a living. And so it changed where they lived and what they did to economically earn things. So now we're seeing these types of changes in the developing countries. Pastoral nomadism, having trouble with that word today, is decreasing in our developing countries because of claims on land for factories and suburbs and other governmental things and borders. And so as those pastoral nomads have a decrease in land, we're seeing desertification, but we're also seeing a change in their lifestyle. This happened in England in the late 1700s. It happened in the United States a little bit, right? Every country in the world was once developing. So now every country in the world is all at a different stage of development. So again, in the Industrial Revolution, machine power replaced human and animal power, and when rural farms didn't need people anymore, everybody went to the cities. Not everybody. A lot of people went to the cities. So the cities grew quite a bit. This is a map that shows how much it grew. This is England before the Industrial Revolution and after. So the darker orange it is, the more populated it is, and the green is really urbanized population. So you can kind of see dark orange blobs where London is before the Industrial Revolution because it was a large city, but it grew by leaps and bounds during the Industrial Revolution, by like 5 million people in 100 years. And so you see these green spots that plop down in England where the industrial centers were. And if you go all the way back to that first map, it kind of mirrors where the coal mines were too. And so As workers worked in the factories running machines that made the textiles and other products, they also became consumers of the things they were making. So the economy starts to drive by the fact that people are employed and have money to spend. So there was an explosion in urban population. So between 1800 and 1900, London grew from 1 million people to 6 million people. And that's overwhelming. When you have that many people, you need to figure out an infrastructure to support that many people. We've talked about this briefly in other units where Manhattan, New York, um, let's say 1 million people live there, but during the day between 9 and 5, people come in from outside to work there. So it has an increase in population from 9 to 5 every day. So the borough of Manhattan has to figure out how to support all of that population that's just there from 9 a.m. to 5 p.m. So electricity requirements, Wi-Fi requirements, internet requirements, sewage requirements, how many toilets are flushing between 9 and 5 versus how many are flushing between 6 and 8 at night when most of the people leave again. So London had to deal with all this. So suddenly there was a lot more sewage. There were a lot more animals. This is before cars, so we were still using horses and oxen to transport things, and they poop. What do you do with all that poop, right? And so pollution became really bad because everybody was burning wood or coal to heat their homes, and it was very dangerous. So in this era, we start to see the government taking control of regulating how people should live. And so the governments would build the sewers, and the governments would regulate the cemeteries, right? This is something you might not think about, but people were just burying their dead anywhere, and you can't do that in a city. Maybe you could do that in the country when there's space, but in the city you just can't do that. And so the government had to step in and say, okay, this is how we're going to do it, and this is what we're going to do. So we start to see governmental involvement in public health during this era. And then as the city grows, it was starting to grow vertically, right? Until we invented steel as a human race, buildings could not be enormously tall, right? And so skyscrapers became a reality during the Industrial Revolution, also necessitated the invention of the elevator. You could not have some of these buildings we have here in China without an elevator to take people up and down. And so this also had to be regulated. You had to make sure those buildings were safe, that they stayed up, that the sewage and the piping and the electricity was all very safe. And that the elevators were regulated so that they wouldn't just fall down the shaft and kill people. So the government starts changing to regulate the masses of people living in one place. Cities also grew horizontally, right? They spread out. This is what we do in America. We have all this space to spread out. Shenzhen can't really spread out because it's hemmed in by the ocean on one side and by the mountains on another. But think of a town like Houston, Texas. There's nothing but, well, there's ocean on one side, but on the other side it's just flat Texas land. And so Houston has been able to spread out. And London and other cities in the Industrial Revolution did the same thing. So in that top picture, you see that green ribbon. That's the Thames River, right? Because if those first cities grew up by rivers, because water was very important for transportation, for food sources, for irrigation, right? So in 1806, before the Industrial Revolution really started affecting population, that's the city of London. By 1862, only 50 some years later, see how much it grew. And so I can live in the outreaches of London and still get to work somewhere else because there's transportation, right? We started having trains and cars and trucks, not by 1862, but there were streetcars in 1862 that would take you from one place to another. And so you could live farther out and transport yourself from place to place in the town. And food could also be transported from the country into the cities to feed the growing population because of improvements in transportation. But industrialization did not reach the whole world at once. Again, it started in Great Britain and then distributed itself through Europe and the United States. And so it caused, in several ways, the rise of imperialism. These European powers needed labor and raw goods to feed their machines and to provide a force to run the machines. And so they recognized the importance of controlling trading posts, so ports where they could dock a ship to refuel a ship, and then those trading ports became colonies because they saw how many raw materials were in these developing countries around the world. There's a definition again for imperialism: extending a state's political and economic power. And remember, there are several ways to do it. Now most people, most states practice imperialism economically, but in the 1800s, they practiced imperialism through colonialism. So colonies provided raw materials, sugar, cotton, food, lumber, and minerals. They also provided labor. And then they also provided markets. So the things that were made in these factories were then purchased by the people in the colonies. They provided ports where trading ships could get resupplied, and they made people richer so that people could invest in new factories and new canals and new railroads and bring infrastructure to a lot of the world. So that cartoon is the mother country. So the imperial state is the lady at the table in the tiara, and then the colonies are just bringing her things as maids serving her. So this colonization and this industrial development really caused the development gap in the world that we see today. Remember the branch line here on this map from Unit 2 in development. The industrialized countries developed first, and so every industrialized country is above that red line. It's the time when they industrialized, right? And so China is industrializing right now, but it's doing what America did 60 years ago, right? So everybody's on a different part of the timeline. So industrialization made wealthy countries even wealthier and poorer countries even poorer. And so that's really the crux of the great divide between the advanced industrialized states, or our core countries, and the rest of the underdeveloped non-industrialized states, which are our semi-periphery and periphery countries. Okay. 7.2. The beginning of this is going to feel like a breeze because it's mostly review, and then we're going to get into some new topics that are a little bit confusing, so hang with me. So we're still on uneven development, which is illustrated by the Brandt line on our map. We're talking about the spatial patterns of industrial production and development. Why is it where it is, right? So we'll talk again about our economic sectors, and then we'll talk about labor and transportation, and this is where it gets into new information. So remember, as we're going through this, that every country in the world has gone through these steps, right? If we think about it in the Rostow section, every country in the world has gone through the 5 steps of Rostow. Everybody's at a different spot in those steps. So all of our Wallerstein core countries weren't always core. They used to be primary. Not that there was that designation because he hadn't created it yet, but the United States, according to this graph here, historically was a primary sector country before the Civil War, right? So most people in the United States were tasked with extracting mineral resources, so farming, mining, fishing, forestry. Most everybody did something like that for a living. There were very few people that did anything else. And then after the Civil War, there was a giant growth during the Industrial Revolution. So most of the population goes into secondary sector of the economy, processing natural resources into products like manufacturing and building. And so from the Civil War into the 1960s, this is how America functioned. And America had a huge boon in industrial development during the World Wars. It got involved in both World War I and World War II fairly late. But before that, they were providing all sorts of goods and materials to warring countries, particularly weapons, tanks, airplanes, etc. So the United States profited quite a bit off of the world wars before they were involved in them directly. And so this helped the United States grow its industry, and those world wars decimated Europe, which were the other industrialized countries in the world, which made America even stronger industrially. And then, starting in the 1960s, it flips again. Now, this really started after World War II, when all of those GIs, the Army boys, came back from the war. There was a big push in America to educate them. And a lot of that education turned into what we called white-collar jobs when I was growing up, being an accountant, being a lawyer, doing something in an office rather than doing something in a factory. So after World War II and really starting en masse in the 1960s, America's economy sector shifts from being secondary to being industrial, to being tertiary, to being post-industrial. And so this will always leave people behind. And I hope we get to watch a documentary called American Factory, which just won an Oscar this year when we come back to school, that highlights this. We'll talk about this more in the later sections about what happens when industrialized areas become post-industrial. So America transitioned itself in the 1960s and 70s and the 80s from an industrial economy to a post-industrial economy with mostly tertiary types of jobs, providing services rather than working with natural resources. So we're talking about things like marketing, banking, design, right? And this is where China is trying to move right now. So China became very industrial in the late 1970s, early 1980s, and now it wants to move to being post-industrial, to moving its population more towards tertiary jobs. But there's a transition there that's difficult. If a factory closes and all I know how to do is put together screws into a small phone and it closes, I'm not trained to go be an accountant. I'm not trained to go create marketing plans. And so you have a lot of lost people in that transition that need re-education so that they can survive in the post-industrial society. And so we'll talk about how that affects an economy and affects the population and affects the cultural landscape. All right, so looking at this graph here, you can tell just by glancing at it, the green is the tertiary, the red is secondary, and the blue is agriculture. So just by looking at that, the ones with the most green and the fewest blue are tertiary and above, are developed countries, are core countries, right? The ones that have some green, more red, and a little bit of blue are our semi-periphery countries. So Brazil and Mexico, because they are industry and service, right? And very smaller portion of agriculture, although in that graph, Mexico still has a lot of agriculture. And then the ones that are substantially blue, mostly primary sector, mostly agriculture, are periphery countries. And so these are still in the primary sources of the economy, countries that are developing. As a reminder, the tertiary sector has become so big we've now added 2 more sectors with weird names for you to remember. Quaternary, which means 4th, and quinary, which means 5th. And so quaternary is our knowledge-based sectors, including research and development, business consulting, financial services, education, public administration, and software development. And then quinary is the highest stuff, the CEOs of the giant companies and the people who run our political states all over the world. So as countries industrialize, the primary sector shrinks and the secondary sector grows. And when this shift occurs, the country becomes wealthier because wages for the secondary sector tend to be higher than the primary sector. And so when wages grow, we have something called the multiplier effect. And that's the potential for a job to produce additional jobs. So the multiplier effect is I open a tire factory in a town, and people in the town can work in the tire factory, and suddenly they're earning money and they have money to spend. So that means that I need more food options, more restaurants, more grocery stores. I need more entertainment options. I need more bars. I need more facilities for them to spend their money on. And so as those businesses prosper, because my tire factory is prospering, which is allowing people to have more income, then the multiplier effect, things grow up around it. Right, so jobs creating jobs is the multiplier effect. So when somebody goes from a state goes from primary to secondary, those secondary jobs create a multiplier effect, which creates more jobs. Tertiary and above is even more. People that earn tertiary and above salaries have more money to spend, and so that really increases the multiplier effect. Now it can work in reverse. So this I was talking about earlier, the transition in the 1970s in the United States from industrial to post-industrial. There were lots of towns that multiplied, that became towns because of the multiplier effect. There was a factory there, everybody had jobs, and so it caused all of these economic boons to rise up in the town. Then the factory closed and the town died. And so this is a picture of a downtown area that used to be booming. Looking at those pictures probably in the 1940s and 50s is when it started to boom, and then the factory closed in the 70s and the town died, right? And so there's not enough income in these towns. There aren't enough people in these towns to support the restaurants and the grocery stores and the bookstores and the five and dime. And so those stores eventually close. We also have a problem in America, particularly where we open dollar stores and Walmarts, these large chains that do what the mom and pop stores used to do in the downtown areas, and then that causes, it creates some jobs, but the jobs are really low paying, so the people that work there don't have a lot of discretionary income to support multiplier effect. So a giant Walmart opens up in a town, and the downtown area with the smaller stores die even further. A lot of developed countries are trying to encourage quaternary and above um, um, post-industrial economies. So cities like Denver, Pittsburgh, and Austin use quaternary jobs to drive their growing economies. That picture is the Dell headquarters in Austin. So your Dell computer was conceived of in Austin. It probably wasn't built there. This is a front office, right? But it was probably built somewhere around here, right? But it was conceived of and designed and marketed in this quaternary section of the Dell headquarters in Austin. And so these quaternary jobs are really high paying. So this really is healthy for a city, because if you have a lot of people that have a lot of discretionary income, they will spend money. So you can build up services for them. They require education, they require entertainment, they require a high standard of living, but they also have the money to pay for it. And so countries really want to encourage more tertiary and quaternary sector jobs to come to their communities, because it really helps the economy to do that. Okay. All right, that's the end of our review of our economic sectors. Now we're going to talk about theories on industrial location. Why is industry where it is? As with all theories and models, this is not 100% applicable in all situations. So keep in mind that every model we talk about is a generalization, a stereotype, if you will. And there are many, many more factors that determine where somebody puts a factory besides these theories that we're going to talk about today. So geographers have developed many models explaining the geographic distribution of economic activities. Can you think of a model that we've already talked about in the agriculture unit? I hope you're thinking von Thunen, right? So that's a model of agriculture, and this Weber theory of industrial location has a lot of the same concepts. So in 1909, and this is a long time ago, right? So this is early industrialization, really. So you have to keep that in mind as you're thinking about this theory. The way the world works now is not how it worked in 1909. So in 1909, a German economist named Alfred Weber developed an influential theory called the least cost theory, right? Since it was developed in 1909, tertiary sector economy jobs really didn't exist very much at this point. And so it is basically a theory that applies to the primary sector and the secondary sector of economy. So it's industrial more than anything else. And so Weber's theory location applies to those economic sectors, not anything above, because of the time frame in which he developed his theory. So his theory is based on removing raw materials, which is primary, and then secondary, making them into something. So where would you put your factory if you're engaged in removing a raw material and making it into a product? So here's what he said. It's called the least cost theory. I'm going to have the same information on 2 slides, just with different pictures. And so it explains the key decisions on where factories locate. The 3 things that Weber is going to think about, and I'll talk about this on several slides, is transportation, and this is the big one. How much does it cost to transport either your raw goods or your finished product? So you're going to want to do that as inexpensively as possible, and where you locate your factory is going to be determined by how much it costs to transport things and what you're transporting. You're also going to think of labor, how much labor costs, and ideas of agglomeration. And I'll define agglomeration officially on a later slide, but it is locating your factory near other things and places that make your factory cheaper to run. So the 3 elements of Weber are transportation, labor, and agglomeration, and that is his location triangle. We'll talk about it more often. The market's at one point of the triangle. In this picture, it's at the bottom. The raw materials are at the other 2 points. This assumes there are only 2 raw materials for every product. Again, it's very simplified, much like von Thunen is. And then where is your factory going to be? Your factory is going to be somewhere in the middle based on the distance between the raw materials and the market. And we'll talk more about this later. So this is the same text as the last slide, but a different locational triangle. So it's got a big orange arrow that says least cost transport. So based on what the raw material A is and raw material B is and where the market is, you want to place your factory where you're going to have the cheapest transport. You mine the gold, you have to transport it to the factory. You mine the silver, you have to transport it to the factory. And then whatever you're making out of this gold and silver, you eventually have to transport to market. You want to place your factory in the spot where all of those combination of transports are as cheap as they possibly can be. So here's the importance here of weight. right? How heavy something is or how bulky it is, how much room it takes up, makes it more expensive to transport. So this is called bulk reducing or weight reducing, right? And I'll explain a little later why bulk and weight are slightly different from each other, right? So one major factor in obtaining raw materials is how heavy an item is. So an industry like copper ore weighs a lot. The raw material that you scrape out of the earth, copper ore, is not your finished product. And there's a lot of weight in that copper ore that you aren't going to use in the finished copper. So you would not want to transport heavy, heavy stuff miles and miles and miles to then make it lighter, right? Because lighter stuff or less bulky stuff is easier to transport. So if you're making something out of copper, your factory is going to be near the copper mine because you don't want to transport all that weight and bulk too far. So that's known as a bulk reducing industry, an industry where the bulk of the final product and the weight of the final product is less than one of the resources that are put into that final product. And copper and other metals are a really good example of bulk reducing industries because the ore that you pull out of the earth is heavier and bulkier than the metal that you eventually get when you process it. Sadly, because it's AP Human Geography, you also might see bulk reducing industry as weight losing industry, or raw material oriented industry, or raw material dependent industry. Sorry. All right, so in these bulk reducing industries, companies try to locate the processing plants near the source of raw materials because the raw materials are the heaviest and the bulkiest, and there's no logical reason to spend a lot of money transporting them somewhere else to process them. Process them right where they are to make them lighter and more manageable for shipping. A bulk gaining industry is the final product is heavier than the parts that are put into it, also called weight gaining industry, market-oriented industry, or market-dependent industry. But I use bulk gaining and bulk reducing most often, and so does the CED. So think of bottled beverages or canned beverages, right? The materials that go into that, the aluminum that is produced or the glass that is produced, then you put water in it and other things. And so the heaviest thing is the final product. The raw materials that go into it aren't as heavy as the final product. So for that, it will be cheaper for you to transport your raw goods to a factory and then have your factory be close to the market because your final product is heavier. So you want to transport the shortest distances you can to get your materials to market. So a bulk gaining industry will be closer to a market than a bulk reducing industry. A bulk reducing industry will be closer to the heaviest resource. Yes? All right, so here's some bulk reducing examples. I talked about copper already. A finished copper bar weighs less than copper ore, and several steps of the copper process are bulk reducing. You end up with all of this material that you don't need. And so most foundries are located near the mines and also near energy imports. Steel was the same thing for a long time. It's an alloy of iron. So the two inputs for steel were iron ore and coal, and both of those things weigh more than the final product, so the factories would be located nearer to the natural resources than to the market. Steel is a iffy one. It's dicey because the steel industry has changed a lot because the way we're making steel now is different. So today, a lot of steel factories are actually closer to the markets than they were in Weber's time. And again, remember, this theory is from 1909, so the way we transport things and the way we produce things has changed a lot since then. But still, the concept of you don't want to transport weight that you don't need to pay for. So you want to try to reduce the cost of transportation as much as you can. Bulk gaining examples, things that weigh more or are bulkier. Bulkier means taking up more space after production. So fabricated metals. So you get metals from your locations all over, your copper from here and your silver from here. And so those factories are to create the metals are located close to the mines. And then they ship those finished metals somewhere else to be put into a machine to create something different, like hand tools and nuts and bolts and cans and knives and pipes and automobiles, right? All of these things weigh more when they're done as a combination of the materials than each raw material weighs on its own. So transportation-wise, you're going to pay less to ship copper somewhere to be made into something big and heavy You would not want to make your something big and heavy very far from the market and then have to transport that big and heavy final product a long distance to the market. And again, beverage production, empty cans and bottles are filled with a beverage that adds bulk and weight. And water is very heavy to transport, and it's the #1 ingredient in beverages. And of course, like anything, there's an exception, right? The exception to the beverage rule is it just applies to bottling and canning. It does not apply to beverages in general. So in the United States, and I don't see them as much here in Asia, we have something called fountain drinks, right? You go to your McDonald's, and instead of getting a bottle of Coke, you get a cup and you fill up your Coke there. And so those fountain drinks, they just ship this syrup, and then at the restaurant they add the carbonation and the water to it. So that's a picture of the filtration system. So you've got the syrup, those little boxes of syrup, and then in the restaurant they have carbonation and water. And so since the water weighs the most, they're saving. So in this sense, it is a bulk gaining industry, right? Because the final product, the Coke in your cup, weighs the most, but they only have to ship the syrup, and then they add the water and the carbonation on site. So soft drinks are also, it depends on what kind of soft drinks you're talking about, whether it's canned or bottled, that's bulk gaining. But the syrup, the carbonation, the fountain drink, soft drink is not bulk gaining. Okay. Hope this is making sense. All right, energy. The importance of energy used to be highly important earlier in the Industrial Revolution. You had to put your factory in a place where you could get energy, near coal or near water. But that has changed quite a bit. We now have petroleum and natural gas and nuclear energy and hydroelectric and solar, right? And so water power was not mobile. Coal was a little bit more mobile, but it was really heavy. But now things like hydroelectric and wind power and solar power is a lot more mobile. I can put up, if it's windy where I live, I can put up a turbine and create energy right there. So with the developments of electricity in the late 19th century, power became even more mobile. I mean, you're all sitting somewhere right now with electricity running to your device, and you can't see the power plant from your house. So electricity and power sources have become very mobile, so factories can be anywhere. They don't have to be close to a power source anymore. Aluminum comes up periodically as an energy-oriented or energy-dependent industry. Even though aluminum is made out of bauxite, which is really heavy, the process of making bauxite, which is the red dirt, into alum, which is a very light white powder, which is then turned into aluminum, that is a very energy depleting process. And so those factories tend to be located not near the bauxite plants or near the market, but where they have the most energy possible to shove into the factory. And so places like China and Canada are major producers of aluminum, but Iceland has this great thing called geothermal energy, and that's the picture you see on the slide there. It's energy that comes from the earth. You take the heat of the earth and convert it into energy. So those folks are swimming in water that is warmed by geothermal energy, and then there's a factory, and it's pretty clean energy. That smoke is not smoke, it's actually steam. And so the aluminum industry in Iceland has grown because the amounts of geothermal energy and the strength of geothermal energy has made Iceland a really good place to create aluminum, even though there's no bauxite. So they have to ship the bauxite, which is pretty heavy, but they're saving so much money on the energy that it makes shipping the bauxite, the cost of shipping the bauxite evens out with the money they're saving on the energy. And that's the crux with all of these industrial locations. You're trying to balance costs so that you can make the most profit. Weber's theory assumes that transportation is going to be the most expensive, but that is not necessarily true anymore. We talked about the flowers. Remember the cut flowers from agriculture, right? So flying something by plane is really, really expensive, but it's so much cheaper to grow your cut flowers in the Caribbean because the land is cheaper and the labor is so much cheaper that cost-wise, you can afford to then expensively fly your fresh flowers to the New York market, right? So Weber, 1909, things have changed a lot since 1909, and the model is not 100% accurate in all cases, much like von Thunen in agriculture is not 100% accurate. All right, so again, least cost theory with Weber is based on transportation costs, how much it costs to get raw materials to a factory, labor costs, the wages and benefits for employees, and agglomeration economies. Agglomeration economies, and this is a vocabulary word, the spatial grouping of businesses in order to share costs. So several factories kind of group in a clump so they can share a railroad, or they can share a port, or they can share an airport, or they can share an energy source. And this allows them to share the costs of business. So according to Weber's model, companies should minimize transport and labor costs and maximize agglomeration. But his locational triangle, which we'll see again on the next slide, is based almost solely on transportation costs. Agglomeration and labor do not appear in this triangle. This locational triangle is only transportation. So here's the triangle again. Your M, this time on the bottom left of your triangle, that's your market. S1 on this bottom right is one of your resources. And again, his triangle only includes 2 resources. Obviously, many things take many more than 2 resources to create a product. So S1 on the bottom right is your first resource. S2 on the top is your second resource. And you're going to place your factory, P, in the place where you're going to reduce transportation costs as much as possible. So on this locational triangle, the P is closest to the market. So the factory is farther away from the resources, but close to the market. So using what we've already learned, what kind of industry factory is this? Is it bulk reducing or bulk gaining? I hope you thought to yourself, bulk gaining. So the manufacturing process makes a product that's heavier than any of the resources that are put into the product. Therefore, you want to save your transportation costs by transporting the heavy things as short a distance as possible. So because it's closest to the market, it must be heavier when it's done than it was with the resources when it started. Yes? So I want to place my factory close to the market. And it's not exactly next to the market, so that means these 2 resources are probably kind of heavy. You don't want to transport it too far. So you want to equalize how much you're spending on transportation based on bulk and weight. And let me again explain the difference between bulk and weight. Bulk means the room that it takes up. Weight means how heavy it is. So one of the fantastic examples of bulk is potatoes versus potato chips. So if you would think of that, you might say, oh my gosh, well that's obviously a bulk reducing industry because potato chips weigh so much less than potatoes. But you would be wrong because the word is bulk reducing. Yes, potatoes weigh more than potato chips, but they're not breakable, right? So you can pile a bunch of potatoes into a truck and ship it off. The same truck can only carry a little bit of potato chips because potato chips have to be air packaged. They have to be protected. They can't be shoved and crammed together because nobody wants a bag full of potato chips that are broken. So that's bulk. So it's not a lot of weight, but it's a lot of bulk. To get potato chips to the market that consumers want to eat, they have to be whole, right? You don't like it when you open your potato chips and they're crumbs. And so that is higher bulk. Even though it's less weight, it's higher bulk. So it costs more to ship potato chips than it does to ship potatoes, even though potatoes weigh more. Does that make sense? So the word bulk gaining and bulk reducing sometimes means weight and sometimes means the space the product takes up. Yes? All right, here are some locational triangles. So if neither raw material loses weight during processing, then the company gains no advantage from locating the factory near either location. So the factory should take place near the market, right? And so when you look at that, if one raw material loses weight when processed, the company can save money by moving production close to that location. This would prevent the company from having to pay for shipping for the full weight. Yes? So looking at these triangles, the one on the far left, our market is at the top in these triangles, and our 2 resources are on the bottom. Right? So our market's at the top point, our 2 resources are at the bottom. So that first triangle, our P, our factory, is closest to the market. So it's going to be a bulk gaining industry. In our middle triangle, the P is closest to the resource that's on the bottom left. That means the resource on the bottom left is the heaviest one. So you want to locate your factory closest to the heaviest resource. You want to save on transportation costs of bulk and weight. On the triangle on the right, the factory is closest to the resource on the right. That means that must be the heaviest resource involved in production. And again, this is really oversimplified. There are very few products that only have 2 resources, okay? All right, so in most cases, both raw materials lose weight, and so when this happens, a manufacturing site will be somewhere in between. All right, so this is an oversimplified theory based on transportation, labor, and agglomeration, but really this triangle is just the transportation part. All right, sometimes cost savings from either cheaper labor or from agglomeration could be greater than the savings derived from locating at the cheapest spot relative to transport costs. So in these cases, Weber recognized that business owners should choose to locate where the cheaper labor or benefits from the agglomeration economies existed. So Weber recognized that his theory wasn't completely accurate. And so he allowed for things like the cut flower market, where we grow flowers in the Caribbean and then spend a lot of money getting them to New York. That the money I'm saving from the land costs and the agglomeration, the labor in the Caribbean, overrides the money I have to spend on transporting it to New York. Yes? Okay, so this is a short little video that is a Powtoon, so it's just music playing around, that describes Weber's least cost theory again to give you another explanation.
Created using Powtoon.
Okay, so the 4 Asian tigers. Do you remember those? So in the video said weight, was talking about weight and not bulk. I like to use bulk because bulk implies both weight and bulk. So remember my potato chip example. Bulk and weight are two different things, but they have the same conceptual connection to Weber. If something weighs more or is more bulky, it costs more to transport. Now back to those 4 Asian tigers. Where are the 4 Asian tigers? Oh, yes. Yeah, I hope you're just talking to your computer and your parents are wondering why. Singapore, Hong Kong, Taiwan, South Korea. Okay, so just like with von Thunen, these assumptions are not real, right? Von Thunen assumed that you had an isotropic plane, so does Weber, and these assumptions aren't real. So the issue is uniformity of area. Weber assumes there's an isotropic plane, just like von Thunen did, but in reality, there are no isotropic planes in the world, really, so mountains and densely populated urban areas and other features can alter transportation costs. Weber's assumption about labor was that sufficient labor is available in fixed locations and doesn't move. And in reality, labor moves all the time. People go from place to place all the time. And in our 20th and 21st century, a lot of labor is becoming automated, which changes everything. Weber assumed that raw materials were only found in fixed locations, but in reality, they're found in many, many locations. And there's something called the substitution principle, is if I'm not near copper, I find another material that will do the same job, and it's nearer to me. And so that's the real condition of the raw materials. His assumption with the product and markets, just like von Thunen, one product, one market, when in reality, you have several markets that you sell to as a producer of goods. Weber assumed that transportation cost was directly related to distance and weight, but cost per mile may decrease as distance increases, and we'll talk about this when we talk about containerization in just a minute. The expense of transportation is weight, but also the cost of loading and unloading, right? And so I want to load and unload as few times as possible. So if I load a truck and drive it 10 miles, I still have to pay to unload it, and it's only gone 10 miles. But if I load a truck and send it 1,000 miles, I am spending about the same amount of money. There's more fuel costs, of course, but I'm spending about the same amount of money as I did when it only went 10 miles, because the big costs are when you load and unload. And so transportation, this is why the flowers can go a long distance, because the big costs are loading and unloading. Yes? All right, Weber assumed that economic factors dominated the decision on location, but there are many more than economic factors. There's emotional factors, there's political factors. It might be really cheap to put a factory in North Korea, but you can't, so you don't. Significance of costs. Weber assumed, mostly accurately, that owners want to minimize costs, but sometimes owners don't care about costs if they can maximize their revenue and market share. And so these types of issues, like Amazon, spends a lot of money to make money, and some business models spend a lot of money to make money, and Weber did not take this into account at all. Other considerations and factors to Weber's theories, and to most theories that we will ever discuss in this class, is not all industries make decisions in the same way. So raw materials are more influential for a steel plant than a factory making clothing. There's also a hierarchy of locational factors, like what's most important, and it changes based on where you are. And so the most important factors to pick a general region or a state is at the top, and then you use a different set of factors to pick that specific spot in that general region or a state. And so we'll talk about those hierarchies of factors later. And another group of factors may be determined to use the exact site of the factory within a county or a city. So this has to do with subsidies and how much is a government going to encourage you to come locate in their country or in their city. We'll talk about this in topic 7.6 and 7.7 in more detail. All right, there are additional models, obviously, there always are, for industrial location and any type of geographical theory. So this model, the Loesch model, kind of just says what we've been talking about the whole time. If you want to put your factory where it's going to cost you the least amount to operate it. So sometimes higher expenses for transportation, labor, and raw materials are justifiable if you result in higher profits. This is what I've been saying the whole time. This is he called it the zone of profitability. Where you can make the most money is where you want to put it. So if you're making a lot of money, you can still spend a lot of money if you're making a lot of money. And Loesch called this the zone of profitability. Yes? All right. This is Hotelling's model, and it's a difficult one. I'm going to show you a video where it goes into too much detail. So the video is going to give you all sorts of vocabulary and information that's not necessarily important for you to remember. So Weber and Loesch are primary and secondary economic sector theories. Hotelling is more of a tertiary sector. It's more about the service industry. And it explains that why competing businesses often tend to locate near to each other. And what they're doing is they're trying to split the market and maximize revenue and market share. So they're trying to locate close to each other because of where the market is and how far that market is willing to travel for their product. And so this is, again, not an industrial location theory, but more of a tertiary service location theory. So here is a video, and again, there's detail in this video you don't need, but pay special attention to when they talk about the two guys' hot dog stands and how they move around to split the market.
Why are gas stations always built right next to other gas stations? Why is it that I can drive for a mile without finding a coffee shop and then stumble across 3 on the same corner? Why do grocery stores, auto repair shops, and restaurants always seem to exist in groups instead of being spread evenly throughout a community? While there are several factors that might go into deciding where to place your business, clusters of similar companies can be explained by a very simple story called Hotelling's model of spatial competition. Imagine that you sell ice cream at the beach. Your beach is 1 mile long and you have no competition. Where would you place your cart in order to sell the most product? In the middle. The 1/2 mile walk may be too far for some people at each end of the beach, but your cart serves as many people as possible. One day you show up at work just as your cousin Teddy is arriving at the beach with his own ice cream cart. In fact, he's selling exactly the same type of ice cream as you are. You agree that you will split the beach in half. In order to ensure that customers don't have to walk too far, you set up your cart a 1/4 mile south of the beach center, right in the middle of your territory. Teddy sets up a 1/4 mile north of the center in the middle of Teddy territory. With this agreement, everyone south of you buys ice cream from you. Everyone north of Teddy buys from him, and the 50% of beachgoers in between walk to the closest cart. No one walks more than a 1/4 of a mile, and both vendors sell to half of the beachgoers. Game theorists consider this a socially optimal solution. It minimizes the maximum number of steps any visitor must take in order to reach an ice cream cart. The next day, when you arrive at work, Teddy has set up his cart in the middle of the beach. You return to your location a 1/4 mile south of center and get the 25% of customers to the south of you. Teddy still gets all of the customers north in Teddy territory, but now you split the 25% of people in between the two carts. Day 3 of the ice cream wars, you get to the beach early and set up right in the center of Teddy territory, assuming you'll serve the 75% of beachgoers to your south, leaving your cousin to sell to the 25% of customers to the north. When Teddy arrives, he sets up just south of you, stealing all of the southerly customers and leaving you with a small group of people to the north. Not to be outdone, you move 10 paces south of Teddy to regain your customers. When you take a midday break, Teddy shuffles 10 paces south of you and again steals back all the customers to the far end of the beach. Throughout the course of the day, both of you continue to periodically move south towards the bulk of the ice cream buyers until both of you eventually end up at the center of the beach, back to back, each serving 50% of the ice cream hungry beachgoers. At this point, you and your competitive cousin have reached what game theorists call a Nash equilibrium, the point where neither of you can improve your position by deviating from your current strategy. Your original strategy, where you were each a 1/4 mile from the middle of the beach, didn't last because it wasn't a Nash equilibrium. Either of you could move your cart towards the other to sell more ice cream. With both of you now in the center of the beach, you can't reposition your cart closer to your furthest customers without making your current customers worse off. However, you no longer have a socially optimal solution, since customers at either end of the beach have to walk further than necessary to get a sweet treat. Think about all the fast food chains, clothing boutiques, or mobile phone kiosks at the mall. Customers may be better served by distributing services throughout a community, but this leaves businesses vulnerable to aggressive competition. In the real world, customers come from more than one direction, and businesses are free to compete with marketing strategies, by differentiating their product line, and with price cuts. But at the heart of their strategy, companies like to keep their competition as close as possible.
Okay, so there's a lot in that video that you don't need to worry about, like the SOS, the socially optimal solution, or the Nash equilibrium. Those are vocabulary words you don't need to know for AP Human Geography. But you do need to understand the concept of the hotelling theory of service industries locating so it can split the market share. It's why things like there's a Starbucks in SeaWorld and then there's a Starbucks not 7 blocks away, and they both do fine. And we'll talk about this more in the urban unit, is how far a distance are consumers willing to go for certain products. So for a cup of coffee, we're not willing to walk more than a 1/2 mile. So there has to be locations that split that market share. We will go a lot farther distance for a higher price thing like a computer. But for a cup of coffee or a hamburger, we don't want to walk that far or don't want to travel that far. And that explains hoteling, why these types of businesses tend to be close to each other. Yes? Okay, so on the other slide, I should have probably put this in a different order, frankly. That spatial hierarchy that I was talking about on the other slide, here it is drawn out. So how I'm going to choose where I put my factory changes based on what kind of spatial analysis I'm doing. So on a large scale, like region or the northeastern United States, I choose the northeastern United States. I choose that region for reasons like where the market is, where the raw materials are, if there's labor, if there's a transportation network, and if there's a supply of power. So I look at those factors and I choose a large region. But then I need to narrow it down. So if I'm choosing a city or a neighborhood, I'm going to look at different factors. I'm going to look at the levels of taxes and subsidies. How much is the government going to encourage me to run my business there? Are they going to cut my taxes? Are they going to give me land and bonuses depending on what I do? Are there specific highways and on and off ramps that make transportation easy in this certain location? Are there railway lines? Are there enough workers in the area that can do what my factory requires them to do? Is there police and fire and hospitals? Is there education and recreational facilities so I can encourage workers to come work at my factory? My workers are not going to want to come live in the middle of nowhere with nothing to do. So I need to make sure my factory is located in a city or a neighborhood that gives my workers quality of life. And then when I get really small, so I've picked a city, so I picked a region first based on certain factors, then I picked a city based on a different set of factors, and now I have to pick a specific property in that city, and I'm going to look at, again, different factors. Is it the right kind of land? Is there enough sewage and water supply? Can my workers and my products get in and out very easily based on the transportation networks? So it's a hierarchy depending on what level I'm looking at. Yes? Another thing that companies have to consider when they're looking at where to locate their factories is labor. And Weber looks at labor very simplistically because in 1909 labor was pretty simplistic. There weren't very many specialized jobs, and now there are. So companies that need specific types of workers often located themselves near major training institutions or colleges that train for that kind of thing. And these types of things are called labor-oriented industries or labor-dependent industries. So we'll talk later about Silicon Valley in California and the Research Triangle in North Carolina. There are a lot of companies located in these areas because of the colleges and universities located around. So UC Berkeley and UCLA and Stanford in California provide the kinds of workers that Silicon Valley needs with degrees in computer science and engineering. If they located themselves in Montana, there aren't as many workers in Montana that know how to do the things Silicon Valley requires because there aren't education institutions up there that produce these types of workers in bulk. Also, where is the other industry that has input in your industry? So let's talk about cars for a second. Cars are really complicated. They're a bulk gaining product, right? The finished product of a car is heavier than any single resource that you put into it. So traditionally, assembly plants have been located close to where the greatest number of customers live. And we've looked at population maps before of the United States. The population center of the United States is not in the middle of the United States. It's more towards the East Coast because more people live on the coasts than live in the middle. As the West Coast grows, it's probably going to change. But right now, the population density of the United States is based mostly in the eastern half. So that's where the car manufacturers were. And they were in the north because that's where the people who bought cars lived. The north was industrialized. The south was not so much. And this is one of the things you'll study in U.S. history if you take it, is that the economy of the north and south were so different. The south was very agrarian. This is what Jefferson and Hamilton, if you've are excited about Hamilton the musical. Hamilton really wanted to create an industrial society. He wanted the whole of the United States to become industrial. Jefferson, who was one of his political rivals, wanted America to stay agrarian, to be primary sector, to grow things and then send them to Europe to be made into products. And so that was the big argument. And in the South, where Jefferson's political ideals were more popular, that's what happened. They were almost entirely agrarian. they needed labor to produce their agrarian economy, and that's where slavery came in. The North became very industrial per Hamilton's economic pattern, and so the North and South are very different. So a lot of industry in the United States has traditionally been in the North. However, foreign companies came in the 1980s and 90s and said, hey, particularly like Hyundai and Toyota, came in and said, hey, we want to build manufacturing plants here because Korea and Japan don't have a lot of space, right? And so they have plenty of labor, but they don't have space for these factories. So they came to look in the United States, and they built their factories in the southeastern part of the United States, Georgia, South Carolina, North Carolina, because there was space there and there was labor there. And those states and regions offered many subsidies to Hyundai and Toyota for locating their plants there because it created jobs. And this is again in the 1980s and 90s. This is late, long after slavery and the Civil War were over. And so these states offer lower costs because of weaker labor unions. We'll talk about this a little bit when we talk about rust belts. But the auto industry is the most unionized industry, almost. I would say it is the most unionized industry in the United States. And unionized means the workers work together to ask the management for things, and then the management has to deal with it because the workers will quit en masse. So they band together and they're stronger together, kind of like a supranational organization, right? And so in the United States, the Auto Workers Union, the UAW, United Auto Workers of America, unionized themselves and then demanded a lot from the car companies, and got themselves into really great situations with benefits and wages. So they were being paid very well, and their benefits were pretty good. But then that became profit decreasing for the companies, and the companies started to go out of business because they couldn't price the cars in a way that made them profitable and still pay their workers as much salary and benefits as they were required to pay. And so the auto industry started to decline. And so in the North, where that red square is, we'll talk about it later, it's called the Rust Belt, a lot of those factories closed. And again, American Factory is indicative of this pattern and is a fascinating watch. It just won an Oscar. I hope we will be able to watch it when we come back. And so auto plants tended to locate in the South after that, but they still located in the East. If you look at it, they're all structured in the East. There's not very many on the West Coast. You also want to locate your company near where somebody needs your stuff. So if I'm making something that goes into a car, I want to locate where the car plants all are. This is called locational interdependence, being near similar factories. We can use the same services like transportation firms and accounting firms. It also allows companies to keep an eye on each other and steal workers from one another. And my GPS, in-car GPS system that I'm making and putting into the Toyota cars, I'm going to locate that near to the Toyota plant because then I save on transportation. And so that's other locational issues, is locational interdependence. You locate near other companies that do similar things or that are doing things in parallel with you that you need for your product to be successful. All right, just-in-time delivery. This is a vocabulary word. Factories do this, and there are people who are paid big bucks to figure out the logistics of this. If I'm running a car factory, windshields and tires and rims, all those things are very heavy and very bulky, and transporting them is expensive, but storing them is also extraordinarily expensive. So I don't want to get all of it into my factory and have to store it until it's ready to use. I want it to be delivered right when I'm going to put it on the vehicle. So I do just-in-time delivery. I only have enough windshields delivered that day that I'm going to put on the cars that day. And so there's millions to be made in figuring out logistics of this type for companies. And so you want to make sure you store just what you need and things get delivered just in time for you to put it into your product and send your product out finished to the market. That's called just-in-time delivery. This reduces storage costs and avoids tying up money in buying inventory that's just going to sit there, so you have more money available to do other things. But there's always a risk of just-in-time delivery not working and running short and having cars sitting on the line that are waiting for windshields that just didn't arrive. And that's actually happening right now with this coronavirus, right? A lot of this just-in-time delivery depends on Chinese factories delivering on time. And they have already, worldwide, globally, just-in-time delivery has this massive shift during Chinese New Year because they know nothing's going to come out of China for 3 or 4 weeks. And so they plan for that. But now that nothing's coming out of China for 2 months, maybe 3 months, everything's kind of on hold. So a lot of factories are having to close because they're just-in-time deliveries of these products that are usually being made right now, that are not being made right now, are putting manufacturing factories all over the world on hold because of just-in-time delivery. All right, transportation. As we talked about, the farther something is transported, the lower it costs. So long-distance transportation is sometimes really a lot cheaper. It's why my banana from Chile is just as cheap as my banana from the Philippines, because the big cost of transportation is loading and unloading, not the distance it travels. So costs rise each time that goods have to be transferred from one mode of transportation to another. So off the ship onto the train onto the truck, off the truck into the store. And so also cost of storage while you're waiting for things to be transported by a different mode of transportation rises costs. So you have to balance all of those factors when you're figuring out your transportation. So companies figure out all of the details of all of this and then decide how they're going to transport something. And there's two things. One is break of bulk point. The other is intermodal connections. Intermodal connections is at the bottom here, but I'm going to do it first. It's a place where 2 or more modes of transportation meet, right? So at the port, a port is connected usually to a rail yard or to a big, sometimes even an airport or a road system, right? So the ship comes in, all those containers come off the ship, they either go on a train or they're unloaded and go on a plane or they go on trucks. That's an intermodal connection, a place where 2 modes of transport meet. Often those intermodal connections are break of bulk points, where you break the bulk down, a place where you take something off a boat and then put it on a train. That's a break of bulk point, where you break the bulk. So the container ship has a giant amount of things, and then you break that bulk and put a smaller amount on trains. And then when a train reaches another place, you break that bulk again and put a container each on a truck. Then the truck drives to a store and you break the bulk one more time when it arrives at the store, and they unpack the boxes. And then at the store they break the bulk again when they unpack the box and put the drinks on the shelf, right? So a break of bulk point is where something gets broken, the bulk gets broken. So I take a giant container and make it into smaller boxes. I take smaller boxes and make it into individual items. All right, containerization. Now we've all driven by Shenzhen port and Hong Kong port and seen containers and probably never even thought about them. But the invention of the container ship changed the world. So here is how.
Everything is everywhere these days. Check out the supermarket. Orange juice from China, nuts from India, swordfish from Japan, lager from Czechoslovakia, scores of European cheeses. You name it, it's there. Not when I was growing up. You'd never taste the range of French cheeses or Bohemian lager beer. At least you couldn't unless you were very rich and could go anywhere when the fancy took you. All that has changed. But it's not just foods. Got an iPhone? Everyone knows it was invented and designed at Cupertino in California. Who knows where the complex bits and pieces of its innards are made or assembled? Apple doesn't say. The industry credits China, Japan, Germany, South Korea, and of course the United States itself. Just think for a moment of the trillions of parts and finished goods moving cheaply around the world every second, a small portion by air, but most by sea. We call it globalization. But the man who basically made globalization a reality in our lives is too little known. This is his story, the story of the man who makes your day. In the Great Depression of the 30s, when millions of Americans were out of work, worse than now, Malcolm McLean was a 24-year-old truck driver. He got a job to take cotton bales from Fayetteville in North Carolina all the way to a pier in Hoboken, New Jersey for shipping overseas. He was glad of the work, but when he arrived, he got bored out of his mind, sitting in his truck, waiting and waiting and waiting on the docks, as the worker ants muscled crates and bundles off other trucks and into slings that lifted the goods into the hold of the ship. On board the ship itself, with much yelling and arm waving, the stevedores then unloaded each sling and saw its contents placed in a designated position in the hold. Malcolm wasn't just bored. He was fuming. His income depended on getting back to North Carolina to pick up more loads in his truck. Out of the frustration, inspiration struck. Wouldn't it be great, he thought, if my trailer could be lifted and placed on the ship without its cotton bales being touched? Yes, it would be great. It would be revolutionary. For centuries, general non-bulk cargo had been shipped in the process he watched. It was called break bulk shipping. Boxes, bales, crates, handled piece by piece. What Malcolm envisaged would have saved him only a day, but it would have saved everyone else something like 2 weeks in loading and unloading the ship. On average, it was 8 days to haul and distribute break bulk shipments in the hold, plus another 8 days at the other end to retrieve and distribute. All that time would have been saved if Malcolm McLean could have just driven his truck onto the ship and at the other end driven it off. Well, today, that concept is a reality. The concept that occurred to Malcolm is known as containerization. It has done more than just save a great deal of time. It's the reason why we have a thriving global marketplace offering us that infinite variety of things. And it's the reason we can move cargoes from remote parts of the world at minimal cost. Malcolm had his idea in 1937. The 24-year-old truck driver sitting in his truck in Hoboken was 40 before he did anything about it. By then, he'd built his one truck into a big trucking company. He borrowed money from an enterprising vice president at Citibank in New York and set about designing the steel boxes and the decks of the ships to carry them, stacked one on top of another. A lot of people thought he was crazy. Inventors always attract armies of naysayers who can never remember how critical they were. For our part, we should remember Malcolm McLean. His first container ship, the Ideal X, sailed from Shed 154 at Marsh Street, Port Newark, with 58 well-filled boxes. It was the beginning of the container era, shrinking our world and enlarging human choice.
All right, right? So containers really change things. It seems like obvious to us, but the idea to save the amount of labor and time by just transporting larger things, larger containers from one place to another, really changed how we ship things. Okay, other locational issues. We'll talk more about government subsidies in 7.6 and 7.7. But governments offer incentives to a lot of corporations in order to encourage them to come. And also international trade agreements and trade blocs change the rules about how businesses function and can change the benefit of having a factory in one place or another. Rules can change, and sometimes factories move because there are different rules in different places, right? Factories moved en masse to China in the 1980s because the labor was so cheap. But now that the labor is getting more expensive in China, they're moving en masse to Vietnam and Thailand and Mexico where the labor is cheap. And then when the labor gets too expensive there, they'll move en masse to Africa. So things do change. And nationally and regionally, governments want to attract industry and encourage economic growth, so they offer all sorts of incentives and tax breaks to get people to come. And then communities separately also offer incentives and tax breaks. So I can choose China, but then if I choose Shenzhen instead of Shanghai, maybe I get something extra for coming to Shenzhen based on what the incentive is. All right, so we've been talking about industrial location, which is a secondary sector. We talked about hoteling, which is a tertiary sector. And then when we're talking about tertiary and quaternary, the locational issues are totally different for these economic sectors. So a retail business needs a market, right? So you need to, if my Starbucks can't be located out in the middle of nowhere, nobody's going to come that far to buy coffee, right? My clothing store can't be out in the middle of nowhere, nobody's going to come that far to buy clothes. But e-tail, virtual retail, can be anywhere because it's just about delivery. And so they need people to work it, obviously, and they need people to deliver it, although drones are starting to deliver things, I hear. So virtual retail just needs an efficient and affordable delivery system. So bookstores used to be bricks and mortar stores in towns near a market, and then they became large chains like Barnes and Noble and Borders, and then those were put out of business by Amazon, and it's just about mail order now. And then just, I think, salt in the wounds, Amazon is actually opening up bricks and mortar bookstores in cities again, because people like to go to bookstores and sit and read and drink coffee. It's an entertainment thing. And so Amazon's actually building bookstores on top of the skeletons of the Borders and Barnes and Noble that they put out of business. It's kind of funny. So this is called flexible location. A service industry or a virtual retail industry doesn't need to be anywhere specific. It needs transportation, and sometimes it needs labor. So it can be almost anywhere. It doesn't have to be near a resource. It doesn't have to be near a market necessarily, unless it needs a lot of people to run, right? So in this type of service industry, call centers, virtual retail, all they need is a good communication system, people who speak the language, and people to deliver, right? And so that's, you've seen call centers in India. There's a joke in America that if my Dell computer breaks down and I pick up the 800 number to call to fix it, I'm talking to somebody in India, not to somebody in America. So these call centers, they don't need much. They need people and they need English, but all other than that, they just need phones. And so that can be anywhere. So this causes companies to be footloose, which we'll talk about on the next slide. So to take advantage of cheap land and cheap labor and places where they can pay people less money. So obviously call centers in India make more sense than call centers in Michigan, because the amount of money I have to pay somebody in India is less than the amount of money I have to pay somebody in the United States. All right, so flexible locations and footloose. So towns and cities try to grab these types of industries because it creates jobs in the short term, but those industries don't stay because there's always someplace better and there's always somebody else to pay less, right? So that's called a footloose industry, minimal location demands. These type of businesses can pack up and leave whenever they want, so they don't really tend to stay a long time, and they tend to actually cause more economic strain in the long run. So on the short term, they provide a bunch of jobs, but then when they leave, those jobs are gone again. So that's called footloose. They can pack up and leave whenever they want. Hopefully you understand my little joke here with the picture. If you don't, look up a little movie called Footloose. That's Kevin Bacon in a small town teaching Chris Penn how to dance. It's a 1980s movie that is a kind of a cult classic from my childhood. It is mentioned in Guardians of the Galaxy. Star-Lord is a very big fan of the movie Footloose. That's what that picture is from, Footloose, because of the footloose locations. All right, prestige and location. So companies that do tertiary and quaternary, they usually have several different types of offices. They'll have a warehouse somewhere that's not prestigious, kind of ugly, out in the middle of nowhere where there's lots of parking and access to roads and railroads. But then they'll have a front office, the prestige location, where the higher paid, higher level employees work, where you have your meetings, and that is your front office. So your front office is the pretty one. Your back office doesn't have to be pretty, and it doesn't have to be located in the center of a town. A front office is usually in a downtown district because you're bringing people in to impress them. You don't want to be out in the middle of nowhere. So the pictures on this slide, on the top is a fulfillment warehouse for Amazon. So you can see in the back there's the sky on the top, and then there's just green, right? It's out in the middle of nowhere, and then it's just this giant warehouse. There's parking and there's roads, but it's not all that pretty. The bottom picture is their main office, their front office in Seattle. And so it's in downtown Seattle, where the land is really expensive, so they couldn't afford to put a warehouse in downtown Seattle. And then they've built prestigious architecture to impress people. So those spheres, the Amazon spheres, where they've got like a greenhouse, and they've spent a lot of money making these front offices prestigious. Back offices are less expensive. Front offices are usually in places where the rent is high. So talking about the bid rent curve, right? You wouldn't want to waste a lot of space in a downtown area where land costs a lot per acre to build your warehouse. You want to build your front office to impress people, but you don't want to take up too much space because you still want it to be cost effective. All right, we're getting close to the end, don't worry. Two things that companies do. One is offshoring and one is outsourcing, right? So offshoring is when I, as a company, send work overseas. I send it not overseas necessarily, but to another country. So if I'm an American company and I send manufacturing to Mexico or to Colombia or to China or Taiwan, I am offshoring. It's not on my shores. It doesn't necessarily have to be over an ocean. United States sending work to Mexico is still called offshoring. This is done when the costs of doing business in another country are cheaper, and this is often due to land costs and labor costs. And when those land costs and labor costs are, you're saving enough money there, you can spend more money transporting your goods from Mexico because you've saved so much money on labor and land. That's called offshoring. So software and manufacturing companies in the United States and Europe often locate facilities in India, China, and Mexico to take advantage of lower cost labor. Outsourcing is different. Outsourcing is when I send my work to another company in my same state, right? So if I'm a company and I'm human resources, so I'm trying to do payroll, insurance benefits, and 401k and retirement benefits, right? And I have a person at my company that does that, but it might be cheaper for me to outsource that to a company that does that all the time because of the economies of scale. That company can do the same job, but better and cheaper for me. So I outsource my accounting. I outsource my human resources. I give it to another company that does that and does it better than my company can, and it becomes cheaper, right? And so companies often outsource specialized things like payroll. So it's another company in the same state, but another company that can do it better and cheaper than you could if you had your own department within your own company doing it. Sometimes companies both offshore and outsource, right? Offshore again means sending it to another political state. Outsource means sending it to another company. So for example, the Boeing 787 Dreamliner was designed in Seattle. And then the nose section was built in Kansas. The wingtips were made in Korea, and the wings were made in Canada. And then the final assembly was done in Seattle. So it was designed in Seattle, and then they outsourced the nose section to Kansas. And then they offshored the wingtips to Korea and the wings to Canada, right? So it's outsourcing when they do something in Kansas in the same political state, but it's offshoring when they send it to another company. All right, guess what? We're done. So 7.3, topic 7.3 is measures of development, which we've already done. GDP, GNP, GNI, sectors of the economy, gender inequality index, human development index. All of those things should be familiar to you. 7.4 is women in economic development. This is a big theme throughout human geography, is how women are being treated. So make sure you're paying attention to this theme of human geography. So the roles of women change as the countries develop. More women in the workforce, equity of wages and power, though, is still developing. And then the concept of microloans. And then theories of development. This is Wallerstein and Rostow, dependency theory, and commodity dependence. That's it for today. We will do 7.6 and 7.7 and 7.8 in another slideshow. Yes? Email me if you have any questions, and make sure this is all clear. Thanks. I hope you guys are keeping safe and healthy and well.